Welcome to Coding Adventures. Today we are continuing what we learned in last lesson about fors, and actually we are discussing today about nested fors, which are basically loops in loops, and this will help us create this pattern. So let's get started. Alright, so before we start this presentation of nested fors, let's recap a little bit what we learned last time about fors. Okay, shall we? So let me grab my notebook really quick and review once more time the syntax for a for loop. So we saw last time that a for looks like this. For, we write the keyword for, and then in between parentheses we actually put three parts. All right, and in the first part we declare a variable and we initialize it with a value. In the second part we are comparing that value with a number, and in the third part we actually write a statement that basically modifies that variables, for instance increments it with 1. And then we open and close a code block here basically. Alright, so and then if you remember from last time we discussed about 5 use cases of for, how we can use fors to repeat things and then to loop through numbers in ascending orders, in descending order, using step of 1 or step of 2. So let's understand again how that works. So basically this variable here that we declare inside this for initialization part, it will be used as a counter, and this variable will be then this block of code will be executed as long as this variable is less than 10, and after each block execution the variable is incremented. So in other words, this code block is executed 10 times. And we also learned about code blocks last time. So between these curly brackets basically we said that we can place one or multiple instructions, and having them placed in a code block, it allows for construct to basically repeat this code block together. So this instruction will repeat together. And another way we said it's easy to remember for is if we imagine this for loops through a series of numbers, and we imagine that basically this part is the from part, this part is the to part, and this is basically the step. So basically if we want to loop from 0 to 10, we change the from part to 10, and then here is the step 1. If we want step 2, we just increment by 2, and so on and so forth. Alright, so this is all that we learned about for, and we did a few interesting exercises with for, both in text mode and also in graphical mode. So let's continue with that. And first exercise that I want to show you today, we're gonna talk about basically nested for, like I said, which fors are fors in fors, so loops in loops. In order to prepare for that exercise, let's open this one that we did yesterday in the previous lesson when we learned about fors. And if we'll run it, we'll see that it's displaying the multiplication table with 2. All right. So let's save a copy of this one. And multiplication table, let's put here multiplication table 2. And the goal for this exercise now is, instead of just displaying the multiplication table with 2, we have this 2 as a constant here, we want to display the multiplication tables with all the numbers from 1 to 10. So we already know that this code is doing the job all right. So it's displaying the multiplication table with 2. We just have to basically repeat the same thing 10 times, right? So we're talking again about a repetition. And what other structure is best for repetition than a for? So, and as you can see, it's pretty easy. All we have to do is take this code that does the job right and place it inside another for. And this is what we call a nested for. So let's see how it looks like. First of all, let's place it entirely, like we said. And we'll write here the for part, and inside this will be the body of for, or that code block. So let's take the entire code that we have here and just paste it here. And we also said we like to ident things a little bit, because see, if we don't ident them and leave them at the same level, we don't know exactly what goes in what. But look, if I'm gonna select this text and press tab on my keyboard, everything goes a little bit to the right, and now it's nice and clean, and we see it clearly that belongs to this for block here. And we also said yesterday that the convention that we adopted here on the channel for, because it's very friendly for beginners, is to basically open and close the curly brackets immediately after for. So we are using this convention, which I find it very, very easy and approachable to beginners. All right, so let's write the parts of for here inside. It has these three parts. So we need to declare a variable, and usually we are choosing I as the generic variable when we want to repeat something like an index, I from index, unless it has a certain meaning. In this particular case, we cannot choose I again, and the reason is this one is already used here. So because it's used here, we need to choose a different variable, okay? So let's choose another one. The other common sense is to use J, like a generic one. But let's say, maybe, you know what? Let's use N. See, N right now is a constant. But obviously we don't want to be just a constant. We want to be a series of numbers. We want to be all the numbers from 0 to 10, because we're going to implement multiplication tables, or from 1 to 10, with 1, with 2, with 3, and so on until 10. So that's basically the purpose of the for above. Or let's name it number, like NO, no. So number starts from 1, will run as long as number is less or equal than 10, and then we increment number by 1. And at this point we don't need this line anymore, but instead what we need, inside the product here, we are doing the product between number, which is NO, which comes from above here, and I, which comes from here. All right, so let's put NO. We had to change N to NO because we renamed that constant. So let's see it. Boom! There's lots of text logged here on the screen. So perhaps let's leave some spaces in between these tables. So we know that this for loop here, this code block, is displaying that one table. So let's put here a println and just leave some space. We just put an empty. So that will leave a one empty line. All right. So now we have the multiplication tables with number from 1 to 10, right? So, and the calculation looks correct. That would be funny if the computer just doesn't figure out the arithmetic here. So, see, nested fors are nothing else than foreign fors. There's no special things about them. They are very easy to understand. We just repeat one more time the same kind of logic that we applied to the first loop. We just repeat everything one more time. We should pay careful attention when we are using this to use different variables. If we, of course, we need to use them different variables, otherwise they may collide. For instance, imagine here, this would have been I. This wouldn't make sense, plus this incrementation here would affect the other one. It would be total mess. It's not when you have 4 in 4, make sure that you are using a different variable each time. So we have this multiplication table. Now if you want to do the exercise together with me here on stream, it's fine. If you encounter any problem, just put a comment in the chat and we'll take a look together. Meanwhile, I'm gonna put this program in the chat so you can use it. Multiplication table 2. And you know, just click on the link, you'll open it in the editor and save a copy just to make your own copy. All right, so see, now we just need a little bit more practice in order to master these nested fors. So what better way to do practice than just create another program, and perhaps this time let's make a graphical one. let's try to build those circles that you saw at the beginning in the intro of the videos. All right, so let's plan a little bit for this one, because we have to do a few calculations. I'm gonna bring my notebook here and let's plan how we do the things. All right, so this is my notebook. Hope you can see it. And let me draw quickly a canvas. This is a canvas. I should have used a ruler. And I have a ruler. So look how we're gonna do it. We're gonna just break the entire canvas into rows and columns, virtual ones. We'll not, we'll not have to draw them, but if we want to really draw these lines, we already did an exercise in the previous one of the previous videos, so you can go back and watch that one. But anyway, for now, just imagine we have these virtual rows and columns. And actually, they're not virtuals, they are rows and columns, right? And we'll make them the same size on horizontal and on vertical, because it will be much easier to calculate things. Yeah, the computer, I hope, will do a better job here than me. So as you can see, we end up with some squares. So and if we'll basically, because they have the same width and height, perhaps we should define some sort of constant somewhere I don't, for the square size. So we can vary it. Maybe we should make it 100 pixels. Now, if we not make the square size 100 pixels, the resolution on horizontal is 800, the one on vertical it's 600. So we should have about 8 squares on horizontal and 6 squares on vertical. And but again, we are not displaying these squares. What we want is to draw a small circle inside each of these squares. Okay, so basically this is what we're gonna plan to do. To draw these kind of circles inside. So first we're gonna draw a row of circle, then we'll figure out how to fill up the rest of the rows, right? So we draw the columns. These are the columns, and these are the rows. So we have we said about 6 rows. And we have about 8 columns, considering that the square size is 100. But you know what? We don't have to work with these numbers. Computer can do calculations for us. So let's try to let the computer do the calculations. So let's start the program here. Let me see. I hope it's a good zooming size so you can see the code. So let's start defining that constant, square size. And it's 100 pixels. It's enough to define just on constant, because we'll just use it for, for doing squares. And now let's try in the beginning just to draw just a row of circles, right? So since there are more than one circle, we're gonna use a for loop. So let's use a for loop. Actually, how many circles can we draw on horizontal? Well, we can draw as many circles as we have columns. So let's figure out how many columns we can have. So we can have a constant. We can name it cols, which is basically 800, which is the resolution on horizontal, and we divide it by 100. And let's do the same for rows, which is basically a resolution on vertical, and we divide it by 100. All right, so now we know the number of rows and columns, which, I mean, this is a pretty simple calculation. We could have put the number here directly, but we don't want to put the number. We want to let the computer do it. Oh, and no, why put here 100? Actually, let's put here square size. So we divide by square size. So later on, we can come up and basically change the square size and see if the computer updates everything in one step. So let's do now, basically we go for each column. So we'll say for each column that starts from 0, and we have this number of columns, and then we increment the column. Here, instead of an I use a variable, and I put a more suggestive name for the variable, col, just to indicate that this is for each column here. And what we want to do, we want to draw a circle. Well, but when we draw a circle, we need to draw it at a certain x and y coordinates on the canvas. So at certain x and y and a certain radius. So that will be the thing for the circle to draw it. And what will be the x? Well, we can calculate it inside the 4. So why inside the 4? Because each circle will have a different x. So basically, in other words, the x of the circle depends on the column here, right? And x will be, it's very simple. We can take a look on the paper in a second, but should be column. So the first circle can be at 0, and the second one should be in the next column. So column multiplied by square size. So basically this will take values such as 0, let's say 100, 200, 300, and so on. So that's because the columns go 0, 1, 2, 3 until 8. And then when we multiply by 100, and since columns are 100 pixels, they should fit inside those columns. Perhaps we should shift them a little bit, but we can do that later on if necessary. And then y, well, we have just one column, right? So we can draw it at any position on the screen, actually. We can put it in the middle of the screen. Let's make a row of circles in the middle of the screen. So y can be 300. That's the middle of the screen. So we draw at position x, y, and radius. What is the radius for the circle? Well, since we want to fit a circle in a box of square size, radius should be half of the box height or box width. So should be half of that. And we can put this one here, or you can define another variable here, let r, and use it here. So let's leave it here just to be like another example to basically see that you can also place expression and calculations directly inside code in the place of where basically the program is expecting a value. You can also do that. You don't have to define variables each time, especially if it's a simple calculation. And let's run it. All right, so we have the circles. Now notice the first circle here started 0, and the reason that we need to shift it a little bit, let me show you, let me bring here the paper. So what's happening, we started the circle somewhere here, see, on the at the 0 coordinate. We place the center of the circle here, so therefore the circle is drawn like that. But instead we want to just push them a little bit, so basically we'll push them with just half of the width, right? So this is half of the square size. Square size. So let's push them a little bit. We'll offset them a little bit so they fit better on the screen. Although it didn't look bad, but if we offset them a little bit, they should just fit nicely. So that should be here. The x, instead of being at 0, the first one basically should start at 50, which is basically half of this one. And then the other one should start at, so basically this one should start at 50, this one should start at 150, 250, 350, and so on. So they still keep the 100 distance between them, but they are a little bit pushed to the right. So here we can have square size divided by 2, which is that 50 value. And we don't have to place this inside the parentheses, since basically division takes precedence over addition here. So let's run it. All right, so we have 3, 6, 8 circles, precisely 8 circles, right? It's not surprise because because that's how we designed the program to draw. So the question is, obviously, the first row will be drawn on top. So when we are drawing on top, here the first time x actually will be exactly like above. We'll start at square size divided by 2, so at 50 pixels. So yeah, that is perfectly the first row. So the question is, how can we draw all the rows here, right? So we have one row. Now what we have to do is to iterate through all the rows. So this is basically for row 0, what we have here, right? So we now have to do for row 1, for row 2, for and so on. One way, again, just as an amusement, you know, without a for, but of course we have a for here, we can just duplicate this entirely. And as for the y here, we just, you know, we just move it to the other row by added 100 or something like that. And we have 2 rows, right? So we add again square size, that 100 is square size. So, yeah, but if we want to fill 6 rows, we have to duplicate the code, and it's not nice. And not only nice, not efficient. So then our best solution that comes to mind is to use a for loop. Yes, that's right. So the entire thing that we have here, we have to repeat for each row. Now, as you can see, the circle we repeated already for each column, right? Now the entire structure, so the entire row, needs to be repeated for each row. So what we're gonna do, we're gonna wrap this entire code block, or that entire for, in another for, and we can use the variable row because we want to iterate through all the rows. So we go from row 0, basically up to the last row. We have the number of rows here in the constant rows, and then we increase the row plus plus, and we're gonna take the entire code that we wrote before, place it inside, and indent it a little bit. Looks beautiful. Now we can see precisely inside the first for, it comes the second for, and those lines comes inside here. Now, if I run it as is, still will not work. Everything will be just drawn on the first row, and the reason is because we are not varying y. So the y on the vertical should be varied based on the row, right? So in other words, it's similar to above. So basically, this is just the offset, because we just bring it 50 pixels down, or square size divided by 2, and then the y for the other row is basically row divided by multiplied by square size. And I hope this is clear. So let's pause here a little bit, not run the program, but explain why the formula for x and y is this, like this one. So look, this is the x, and let's say yeah, let's say the y, because we have a little bit more space. So here is y, and y-axis goes this way, and the rows variable also goes this way. Y is here at 0. To draw the first here is basically 0. At this point, y is 100. At this point, y is 200. At this point is 300. So basically we can see a pattern. Row 0 has y 0. And this is row 0, by the way, because as many things in in programming, when we have a series of numbers, usually they start at 0, and you know, in the beginning programmers are a little bit confused by this, but many series of numbers coordinate systems start at 0, and the same happens as well here. We saw last time also first coordinate is 0. Also we consider ourselves row being 0. We could, well, since we are designing this program, we could have made our first row as being row number 1, but just to be in alignment with this convention that things start at 0, our first row is 0, second row is 2, third row is 2, and so on. So basically for the first row, the coordinate is 0 here. For row 1, it's 100. For row 2 is 200. So as you can see, the pattern already emerges. It's basically like we said here in the code, is the row multiplied by the square size. And this expression in front is just to shift it a little bit to the right and a little bit down, just to fit also the first row. So yeah, I think the program is completed already. I left you a little bit in suspense. Let's run it. Yes, and we have this nice nice image of circles. And now let's play with the constants. If we did things right, program should automatically recalculate everything. And the only constant that we want to change is the square size here. So let's then make them smaller, 50. All right, we can fit way more circles on the screen. If we make them 10, very, very tiny circles. So let's put back 100. Yeah, so we can see them better, right? So I think this task is accomplished, right? But I think we can still do a little bit more here. So what's better than a 4 nested in another 4? Well, the answer is another 4 nested in a 4 in another 4. So let's place the third 4 here. And what we plan to accomplish here is basically, instead of a single circle here, we plan to draw a series of concentrical circles. And if you remember last time we did in the previous exercise yesterday, when we draw that concentrical circles, we can also apply the same technique and basically draw multiple circles inside, varying the radius this time, right? So if we look here, we have a fixed radius, which is this one. Let's take it in a variable, you know, this time we can take it in a variable. It will be much easier to see it. Let r equal square size, should be the same. And we want to now, instead of having this fixed, which is basically, as you can see, because square size is 100, this radius, it's 50. So we want to, for each of the circles that we draw on the screen. So we have here, how many circles? 8 times 6, right? Lots of circles. For all these circles, we want to draw actually more circles. We have to draw a series of circles. Let's begin. So the way we're gonna do, X and Y will remain outside of the third 4, because all the circles, the concentrical circles, will have the same X and Y. So we don't place them X and Y inside, otherwise they'll change with the repetition. So they'll remain outside, but these two lines, because the radius will vary, and this one, we'll place them inside the 4. So we'll create a 4, and actually name the variable r, and we'll get rid of this one. So the radius will start at this value, which is the biggest circle, and radius will go as long as it's greater than 0, with decrement maybe by 5, right? And then we don't need this line anymore, because we have one that varies the radius. So it's a single 4, and it's similar to the one that we saw yesterday. So let's run it. Let me save it first. Again, save often. In case the computer crashes, you'll not lose your work. Second reason, when working with 4s, if you make a tiny mistake, you run into the chance of going in an infinite loop. So instead of loop to finish, for instance, instead of finishing on 0, if we put the condition wrong, the loop will take forever. And in that moment, the browser freezes and we have to just kill it and start all over again, and we'll lose our program. And I tell you another tip. Run it often to avoid accumulating errors. Okay, so let's name this circle pattern, and save it. Right, and now it's saved, we can run it. Oh, I is not defined. Where I put I? Oh, here. The variable is r. Okay. All right, we have now concentrical circles. How many circles do we have? Well, first of all, lots of them. If we start a calculator, we'll figure out in a second. So there are 8 on horizontal and 6 on vertical. 8 times 6 times. And now we can count these ones, because we don't know, we didn't count them before. But they should be 3, 4, 5, 6, 7, 8, 9. Or we can calculate. Let's say they are 9. Maybe I missed. But there are about this number of circles on the screen, and you saw how fast the computer drew these circles, boom, in one picture, just like that. Usually, and the reason I mentioned how fast is because in the moment you put 4 in 4 in 4, actually the performance degrades a lot by an order of margin, because the entire thing gets repeated again and again. And if you are not careful and you put here expensive operations, we'll see that in the future when we're gonna touch on the game design. If you put here expensive operations, these things may take a long time to complete. But a circle is nothing. It's drawn in a blink of an eye. Let's see it again. Looks beautiful, right? I like it. Let me share it with you. Pattern of circles. And now, you can play with the program. Now this is calculating mathematically, but you can play with the program perhaps here. Why the radius should fit exactly in that box? You can make it bigger. What's happening if you make the radius double here, just for fun? I don't know. See, we create all sorts of nice patterns on the screen. Perhaps the radius, maybe instead of divided by 2, let's divide it, or let's multiply it by 0.75. So yeah, it's 3/4 of the full radius. You still see this pattern. Or maybe the radius here, we can decrease it by 2 instead of 5. We start seeing more of weird moire patterns on the screen. Let me make the program back again here, and we'll run it, and it's running as again. Now, we always said to put comments in the code, and it's a good practice. Let's do it together here. So this one is square size. It's exactly what it says. It's pretty trivial. Vary this number, change this number, and rerun the program. These two, don't change them. This calculates the number of columns, of rows and columns that fit on the screen. All right, and then we can say, put a comment here, loop through all the rows, and put here again, for each row, loop through all the columns, and then we say here, for each circle, draw inner circles. And then, so basically draw them concentrical. So this is a commented programs. Now, perhaps these comments are a little bit too much for this particular small case, but you know what? It never hurts. I'm gonna save the program. Comments are very good to remember what we did if we, in the future, our future selves looks on the program, or if we're sharing with our colleagues. You know, it's always good to have comments. And only comment what makes sense. All right. Now, since this is fun and it produces such interesting things, I thought about a pattern. Let me see if we can reproduce that pattern. I thought about a pattern that kids in the 80s and 90s developing video games used to basically do it a lot. Is basically creating a wall of bricks and all via lines. So let's see if we can reproduce that here. Back then we used a different technique. So now we're gonna use only what we learned until now. So only lines and for loops. So let's see. So we start again with a canvas. And let me just draw the canvas really quickly here. And I have a ruler, actually. I can be quite precise, but you know, it's just a small scribbling is also fine sometimes, just to better to design the program. And we're gonna split it again, the canvas, in some rows and columns, you know, like before. And so we're gonna split it in some rows and columns. I'm not gonna draw all of them this time. So let's draw just here 2 columns. Let me draw here 1, 2. Right? So the pattern goes like this. We want to do this to draw some bricks, and if you remember how a wall, so basically how a wall of bricks looks like, it's something like that. I'm gonna draw it here really quickly. So bricks are displayed in this way. Well, we can do this one in multiple ways, but in this way we're gonna do it by going inside one of these squares and draw this kind of pattern. We basically, okay, and let me make it in a different color just to be able to see it. Actually, it's quite visible, right? So we draw this one horizontal lines and two vertical lines. And we just repeat this. We repeat for each column and then we repeat for each rows. And the idea is that basically this one, imagine when it gets repeated again, this one will get put together and a pattern will start to emerge here. So hopefully we'll end up with this pattern, okay? So this is the thing that we want to draw inside each of those squares. So I'm back here in my code. I have a blank code editor and we're gonna do the same. Basically the technique is the same. We split the canvas in a number of rows and columns, and then we iterate through all the rows and through all the columns. And then when we go in the drawing area, instead of drawing just a circle, we'll try to draw that kind of drawing. And you know, to speed things up, we can actually start from the previous program and just modify that line. But you know what? Let's do it differently. And it's a good thing just to practice typing and rewatching it again. So let's focus first on the drawing in the middle to make sure we get it right. Right? So let's do that one first. So let's assume we want that square will be at certain coordinates. I don't know, maybe that square will be at 300, 400, and let's say square size, it's again 100, const or whatever. So we want to draw basically, first of all, let's visualize it at x and y, square size. We are doing a rectangle, but both sides are the same. So we just place here a small square. Let's put it at 100, 100. Right? Let's try to actually draw that that kind of pattern inside here. So let's make sure we have right one pattern, and then we're gonna multiply it. So the way we said we have to draw a line in the middle of the rectangle, right? So basically we'll have the axis the same as the rectangle here, but will be halfway down. So that will be basically a line. We'll start at the same x as the rectangle, but halfway down. So we'll be at y plus halfway down. So it's square size by 2. And then we'll go to the right, x plus square size. We'll go till the end of the rectangle. So, and on vertical should be at the same coordinates as this one, because we want to draw it horizontal. Let's see it. All right. And let's draw the other line, maybe perhaps at 1/3 here, and then the other one 1/3 towards the end, or 1/4. I don't know, 1/3 or 1/4, something like this. Let's draw this. Yeah, maybe 1/4, because here is middle, and maybe you should split us in middle. So let's do it at 1/4, the other line. So the other line, we should draw it at x plus 1/4 of this one. So this one divided by 4. And then y is the same as the rectangle. And then when it goes down, the other end of the line should be at x. What we try to do here, let me run it again. So, we want to draw this one until here. So the other, yeah, the x is the same. X is the same as this one. But y is y plus half of the entire square, right? Because it needs to stop there in the middle. Let's see it. Yep, we did it right. So let's draw another one here. So it's basically a 3/4 here instead of, yeah. So the other line will be line starts at x plus plus this guy divided multiplied by 3, and then down is actually starts in the middle of the rectangle of the square and goes up to the end. So up to the end is basically y plus square size. Let's see if I didn't mess up these calculations. If not, I'll do it on paper. Oops, I don't see them. So it's x plus 3, okay. And on horizontal, it starts at here. Oh, I didn't put the other x. So should be one more pair of coordinates here, right? Yep, we have them right. So we have at least one square, right? Which is good, because all we have to do right now is just to repeat this thing over and over again, okay? So either we write again those 4 rows and 4 columns, but we can, now I think it's fine. We can just basically go in there, and in the previous program, and instead of the circle, we just, boom, place these lines here. So let's copy them. So this replaces our circle. Let's comment them out just to see what I'm saying. So this replaces the circle at x and y, and the radius, whatever radius was that one, was square size by 2 initially. So if we don't, this circle, if we leave this circle in place, they should basically be at the same kind of, no, the circle, because it's, yeah, the square starts in this corner, and the circle it's middle here. Maybe we don't have to shift it anymore. So, all right. So let's basically get these lines here. Let's keep this program. It's good. We can name it 1 brick, just in case we mess up things and we have to refer to it. So this is 1 brick. And now I'm gonna copy these lines, keep them in the clipboard. I hope I'll not lose the clipboard. Go in my previous programs, go in the circle pattern, save a copy, name it bricks, and now we don't need the entire thing here. We don't need, see the circle, but here even we had the concentrical circle, so we don't need that. And instead we are pasting the 4 lines here. We are indenting a little bit, and as we saw, probably we don't have to shift them a little bit, because for a circle the hotspot was in the middle, so therefore that's why we shifted, but for a rectangle it's in the top left corner. So yeah, oops. Yeah, first of all, let's not shift them. So basically we don't have this this snippet here. And now the reason it's doing that is because we left the rectangle and we said we're gonna leave just the pattern. So let's remove the rectangle. We run again. See, coding, it's all about iterating through things until you fix it. Nobody gets it right from the first time, so don't feel discouraged, okay? Just practice, practice, practice. I think in order to make it right, actually, we have to draw not only the 2 vertical lines and 1 in the middle, let's draw one at the top as well. So basically here, if we are looking on the paper, I think we have to draw 1 more line just to have the pattern right. So we have to draw also this line at the top, and then when these things will get repeated, yeah, because this line will go on the bottom as well. So here, yeah, but we need just one on the top. We don't need it on the bottom because it will get repeated and will look the same. So let's draw another one here at the top. So let me go before this line. So this line, it's pretty easy. Start at x and y, exactly like the virtual rectangle, and goes the second corner. It's x plus square size, precisely square size. We go to the other end, and y, we keep y because we make it horizontal. So this end of the line is the same coordinate as this one, so stays perfectly horizontal. All right! We have some bricks! Aren't these cool? And now we can play if we want with colors, but that's fine. Let's try to change the square size here a little bit, 50. Yeah, they look quite all right. So let's put a comment here. So basically here is a draw a single brick. So see, because of the pattern, they get repeated and repeated, and we get this cool looking effect. It looks like a wall of bricks. And as I mentioned, there are multiple techniques to do this one, but with the things that we learned until now, just the basic fors, we can achieve this one pretty easy with 2 nested fors. So basically, exactly the topic of the today lesson, nested fors. All right. Oh, this looks cool. I like it. Quite realistic, as a matter of fact. Let's play a little bit more with this one. Let me save a copy. Let's try to see if we can create other patterns. Let me, you know what? Let me just draw a rectangle here instead. At x, y, square size, square size. So let me just draw an empty rectangle. Yep. We just, so see, notice this actually this effect we also achieved it in the previous lesson, but it was done differently back then. Back then we just drew a series of horizontal lines and a series of vertical lines. So two fors, but not nested fors, one for after the other. This time this effect is achieved by just doing a series of rectangles in 2 nested fors. These times are nested. Let me see if I can find the other one just to compare them side by side here really quickly. If I'll be able to find it, it should be, oops, that's not here, should be under my programs. 4, sum of number, factorial multiplication, circles, lines. If we run it, yep, this is the one. So let me put it side by side and well, hide myself and just I let you 1 minute to inspect them. So as you can see, the first example here, what we did last time, the 2 fors were basically not nested. We just drew some lines, but by the careful placing of the lines, these lines intersected and looked like there are some squares there. This time we actually drew some squares and we drew them basically in this kind of nested for loops. All right, so let the timer go. We don't need 1 minute to inspect that one. We have other goal in mind. Let's do some nicer patterns here, perhaps. So with the bricks, we just had that line like that and 2 lines inside. Let's do some axes here. Let's see how it look like if we do 2 axes here. And we also get the chance to play with the math here. So we'll do a line. The first line will be diagonal, this diagonal. So starting in this corner and going so in the top left corner going to the bottom right. So we'll have a line starting at x and y. And now the other one will be x plus square size and y plus square size is precisely that. Let's run it. Actually, let's run it after each line. All right, we have the diagonal lines like that. But notice, we are not drawing full lines like from here to here. Again, we are doing just these smaller lines inside each square, but they just look like that when they get put together. Let's draw the other diagonal to see how it looks like. So the other one should be x plus square size and down is y, and then the other one is x and down is y plus square size. So yeah, I think these are the right coordinates. All right, see, we have another pattern here. Let's save it. And I'm wondering if we eliminate the rectangle, how it look like. Yeah, it looks like this rhombuses, this, yeah, but we can leave the rectangle in place. They look pretty cool, right? Maybe we can place even a circle here in the middle or do all sorts of fancy stuffs. Actually, I'm gonna leave this up to you. Let me share this one with you. Did I share the brick ones? No, I didn't share the brick ones and I like that one. Let me share quickly the brick one and then this one with you. Okay, so give me a second. Let me find my chat here. Bricks. All right. And then Yeah, and Pavel says looks better with 50 on the chat here. Yeah, I like it with 50 as well, that size. Probably you are referring to the square size. So let me check the other pattern as well. So put here patterns. All right, I shared both of this one with you. What else can we do to practice more force? Programming is practice. Well, I have an idea. Remember when we saw basically these sprites last time? So let's pick a sprite, perhaps this guy, this guy little here. There is a lesson there I interjected in the playlist, so go watch that one if you want to see working with sprites basically. So yeah, this is this guy is not animated. What? Let me hover over it. Oh, it says walk, has also an animation, a subtle animation perhaps. Let me try this one. Whoa, look like he's running, not walking. Anyway, question is, can we have more of these guys on the screen at the same time, walking, running, doing their things? Of course, sitting in place. Actually placing them again on a row and matrix, row and columns type thing. Let's try. So let's define here number or rows. Perhaps we should choose 6 rows, and columns, perhaps we should pick 8 columns. So basically we'll choose 100 pixel for column and row. And we don't have to vary it because this guy has a fixed size. Actually, yeah, we can vary the size of this guy as well, so we can link them together, but it's fine for now. Let's just not complicate the program. So I'll just type it really quickly. And the way we are typing it and we are rationalizing, we say for each row and then for each column, put a sprite. So let me see if I can get it right from the first time without running intermediate steps. For each row that starts at 0 and the row goes to up to the number of rows, we increment the row. And inside the for, we want to do the inner loop. For each column that starts at 0, the column is less than number of columns, so increment the column. And now we want to do the thing here. Okay, all right. So 400, 300 also represent the x and y where we want to place a sprite. So let's figure out what will be x and y. Actually, you know what? We don't know exactly. Yeah, we don't need. We just let me multiply. Is not row. X goes on horizontal from left to right, so it's the way columns go. So here x is column multiplied by 100, and y, because it goes on vertical, is the way rows goes. So it's row multiplied by 100. And this will be our x and y. And let's run them. We have tons of happy characters walking, running. Let's shift them a little bit. 50 pixels should be enough. Did they look cool? So yeah, should be 48 of them if they fit here. Yeah, 48 animated sprites walking in place. We still cannot make them move, not yet at least. Bear with me in a future lesson. But for now I think looks pretty cool. So let's name this one animated sprites or lots of sprites. All right. I guess I should share this program with you as well, right? Lots of sprites. It's this one here. And let's do one more exercise, only one, and then wrap up the day. Let's do a serious one, right? We are at the math class. Let's plot. I'm thinking now plotting the sine function, right? Sine function. So what do we know about the sine function? First of all, well, we need to understand exactly how we are working with the sine function. It's a trigonometric function. The plot should be, let me show it to you. Sine function. Okay, let's go to Wikipedia here really quick. Yep, let's click on this graph. So we want this kind of to achieve this kind of graph, the red one on the screen. Here we see that it goes from 0 to 2 pi, and this is because probably they are using radians. We're gonna use degrees, and the reason is degrees are easier to understand by multiple people, and also the default type of angle modes in CodeGraph environment, it's also degrees. So basically we'll go from 0 to 360 degrees, the full circle, and then we know that the sinus, the sine function will produce values in the interval -1 to 1. So for all the values in the interval 0 to 360 will produce -1 and 1. Actually, let's draw it on the paper, this one, because may get a little bit tricky to calculate if we don't get the values right. So what we want to achieve is the following. All right, we have the canvas, and starting somewhere in the middle of the canvas, we want to do the sine function. Oops, I should touch the bottom here. So you know, we know already that the canvas has 800 pixels on horizontal and has 600 pixels on vertical. So we need to somehow map. So when we'll do it in degrees, we want to map all the 0 to 360 degrees into 0 to 800 pixels on horizontal, right? And when we do it on vertical, we want to go from 0 to 600 pixels basically, and map it to values of the functions which are basically they vary between -1 and 1, so between -1 and 1 kind of, right? So let's focus on this horizontal thing. So the question is, if we split the entire interval of 800 pixel in 360 smaller intervals, what will be the actual size of that thing here? So but this is pretty easy to calculate actually. So if we have from 0 to 360 degree here, so basically here we can put x, and we find out it's 800 by 360, the size here, right? So it's a simple rule. So that size here, it's 800 by 360, right? So we can right? Yeah, should be right. So so let's basically this is, so basically let's name this one, let's say this is the distance, this whatever variable d, this is the distance. And then what we want to do, we want to do a for to go through all the angles from 0 to 360, and then for each angle we'll figure out what is the value of the sinus in that point. And actually this line is pretty difficult to draw, so what we're gonna draw, some vertical lines like that, right? So this will just go like this, because these lines are much easier to draw, at least at this current moment. And I saw this kind of representation on the P5JS website some time ago. On the CodeGraph website, there is a representation where sinus is drawn like a line. On the P5JS website, there is drawn with this line. So we're gonna take this approach basically. And the reason I'm saying it's much easier is because we draw as many vertical lines as angles. So basically we draw 360 vertical lines, right? One for each angle. And the height of a line is basically nothing else than well, sinus of an angle in that point. And because, well, it's not just sinus of an angle. Yes, that should be the value, but sinus of an angle is between -1 and 1. So you know what, we're gonna multiply it by 300 here, which is half of the screen, times 300, just because we want to stretch that -1 and 1 interval and stretch the interval on the entire canvas, right? So if we stretch it, basically if we multiply by 300, we should get the upper part, and then it should go the bottom part as well. Right, so I think we have all the elements in order. We are missing one thing that I'm gonna show you today, is basically how we calculate the sinus of a value of an angle. We never touched this one. It's a simple mathematical function, but you know, you'll get it in a second. So let's start by that, defining that, what is the space there, although we don't need it at this moment. Yeah, you know, let's have it here, it doesn't hurt. So this one we said it's 800 divided by 360. So these lines will be drawn at this interval apart, basically. And now let's loop. And you know what? Although the lesson is about nested loops, this exercise is actually simpler. It's just a single for loop. We just loop once through the angles. Perhaps we should have done it yesterday, but you know what? It's still in the same bucket with for loops. So I hope it still fits with the lesson. So let's choose a variable. We can name it angle, right? So angle goes from 0, angle is less than 360, and angle plus plus. We iterate through all the angles here, right? And then we need to basically find out the value for an angle. Let's say we take this in a variable, and as I said, it's, look here, this is the new thing. It's, we use the function sine, and we put here the angle, and I said function. So let's analyze this construct a little bit. Until now, we saw to assign to a variable a number, perhaps like 100. We also saw to assign a variable an expression like 2 plus 3. Now we see a new construct here, which looks pretty intuitive, right? In math, you write it all the time. This is actually a function, and this is actually the technical term that JavaScript is using for these constants. And notice, this function probably, I mean, for sure, it returns a value, right? So when we invoke this function will produce a result. And the way we are putting that result inside the variable v, we just use the same form as before. Because as always, what is on the right, it's put in the variable on the left here. So basically this expression is evaluated, and the result goes here. Here 100, it's a constant, goes directly. Here the expression is evaluated, and the result is put here on the left, right? So that's one thing. So this is new that we are learning today about, and just to make a little bit of a bridge into a future lesson, just look a little bit about the invocation of this one. So it's written like that, right? So of course we are reading a value, but even without putting that value into something, when it's looking like that, it just looked like any other so-called instruction that used until now. So basically there is a keyword, we had circle. There is a keyword, and in between parentheses there is something, you know, some argument. And the circle we had the same. The only thing we didn't have, you know, something like that with circle. Actually, it's not even working. And there is a simple reason for that. Is because sinus, I mentioned already, it's a function. It says the sine function. But more than that, what we used to call until now instructions or commands, just to be very approachable to beginners, like the circle and the rest, are actually called functions in a technical term. And we'll have in a couple of days from now a lesson especially about functions. Okay, so anyway, for now I hope this explanation makes sense. I'm gonna remove these other guys here. So we are taking the value here in a variable, right? Probably won't be enough because we expect sine to return between -1 and 1, right? So if we're gonna start to plot the height of that line as being this one, those lines will be tiny, but we can leave like that, and then we'll magnify them. So let's leave them like that. The question is, what will be the x for the lines? And the x for the lines is pretty easy calculated. It's based on the angle, right? So it goes from 0 to 360. So it's angle multiply by this constant that we name it here d, right? It's exactly like with the other things that we placed on the horizontal or vertical before. So we just paste them apart. And the y Well, the y can start in the middle of the screen because we want to go up and down. So y is just a constant, it's 300, right? So at this point, we have the value, which will be the height of the line. We have x and y. Let's draw the lines. Line, start x and y, which is basically on the horizontal line. And now they need to go up and down. So x will remain the same, but y will be added with the value. So this being the height of the line is basically we're adding with this value. And probably will not look right. Again, this one should be between minus 1 and 1. Let's run it anyway. Yeah, I think if I'm squinting into the here really closely, I think I see a sine function, but I think it's because of the multiplication. So let's just multiply it with 300 like we said, so we can basically just make this let's put the comment on top. So, sine returns values, and we can say here we multiply with 300 to stretch on the entire screen, or vertical, right? So let's see. Yep, there is one problem. If we go on Wikipedia, sine again, if we see that sinus, it goes up and down. Ours goes down and up, and there's simple fix, but let me show you what's going on here. If you know, in math, regular Cartesian system has x going to the right and y goes up, right? In our system and on computers, not only in CodeGapi, but in not only in all the other graphical environments, on virtually, not all, I should not say all, in virtually all of them, or most of them, x is still going like that, which is fine, but y goes down, right? So, but on the other hand, sine is a mathematical function, so it returns a mathematically accurate result. But when we plot them on a coordinate system that is turned upside down. So here, instead of adding the value, I think if we're subtracting, we should complement to that thing. Yeah, and they just go in the normal way. All right, so this is the okay, this is a sine with lines. This is a sine graph with lines, and with a single 4. And yeah, these lines are so squished together because here we are divided 800 by 360, so they're very closely squished together. You know, if we don't step the angle so often, if we do the angle plus equal 5, maybe not go from angle to angle, yeah, we can have, you know, we represent fewer angles on the screen, so lines look a little bit more spaced out. What else we can do? Yeah, why not go beyond 360, right? So let's see the full sine effect, because this is a function that repeats itself. So instead of going to 360 here, why not go to 720? So we double it. And I think we should do the same here, because yeah, and see, the sinus repeats itself. So perhaps we should have a constant n, how many iterations we want, and then here it's 360 times n. We divide by these guys, and this is 360 times n. So for one should be the same as, yeah, like that. We try with 2. If we try with 3, yeah, we can see. And now we elongate it a lot. So just remember, at this scale, here is 0, here is 1, and here at the bottom is -1. So it's not on the scale on horizontal and vertical. And but yeah, other than that, it looks pretty correct. So we have the sine function. I'm gonna save it here. Perhaps I should leave this as an exercise to you. I'll not share it on the chat, but should be pretty easy to reproduce it. Again, there is also another sine example, but it's more complicated on the CodeGuppy website. So there is a simple one, like something like this one on P5 website, and but this is our approach to the exercise. So I think with this one we can wrap up the lesson for today. Let's take a quick look here. See how many programs we build in just a couple of days. So we're continuing our lesson tomorrow. Perhaps tomorrow, I hope tomorrow. Yes, and I plan to discuss about conditionals, so if statements, how to take decisions inside code using an if statement. So thank you for watching, and see you tomorrow. Happy coding!